This video is for you if you want to set up a productive workplace where you feel comfortable with doing Python for machine learning and data science, but also you want to know how to manage projects with virtual environments. You want to know how to work with Jupyter notebooks in Visual Studio Code and select a kernel for notebook. The video is a step-by-step demonstration. You can check two relevant guides in the description of the video. There are plenty of ways to work with Python and Python-related tools for machine learning and data science. If you are new to Python or want to try something different, you may consider, for each of your projects, you create a virtual environment. Each virtual environment is a folder with its own version of language and installed libraries. It's like you give each project a separate and isolated directory. Conda is a management tool for package dependency and environment. Conda supports all the languages. We use a conda command to create a new virtual environment. We use conda command to install packages into an existing environment. We use conda command to remove an existing environment. We use conda command to activate an existing environment. Then you can work with the project in this active environment. We use conda command to update a package in a virtual environment. We use conda command to remove a package from a virtual environment. We use conda command to search a package in a virtual environment. We use conda command to list all the packages in an environment. Jupyter Notebook is an interactive development tool. In a notebook, you organize both code and text content by cell, and interactively write and execute each cell. By combining code, execution results, and text content in a single document, you allow other people to reproduce your work. Jupyter supports over 40 programming languages, including Python, R, Julia, and Scala. Jupyter provides two web-based interfaces, JupyterLab and Jupyter Notebook. JupyterLab is the next generation notebook interface. The extension of a notebook is IPython, Interactive Python Notebook. Markdown is a plain text formatting syntax. In a notebook, you can use Markdown to format the text content in a cell. We need to install Jupyter in order to render a notebook. Jupyter is a new project from IPython. Project IPython is focused on interactive Python. Jupyter aims at language-agnostic components, providing a consistent set of tools for interactive computing workflows across multiple programming languages. Jupyter contains a powerful interactive shell, a kernel for Jupyter, and support for interactive data visualization. The kernel is a part of the backend, responsible for executing code written by the user in the web applications, including Jupyter Notebook and JupterLab. In a Python notebook, ipykernel executes the Python code. If we install ipykernel in a virtual environment, add the environment as a kernel, install Jupyter and JupyterLab into the environment. Then we can connect a notebook to the kernel and access the environment. The kernel will render the Python code in the notebook. Python is the primary language you do for machine learning and data science, you should try Anaconda, which is the most popular platform for Python. Anaconda offers individual edition for free. Anaconda contains Conda, so you can access Conda from Anaconda installation. Anaconda is actually a suite of powerful components, including a bundled Python distribution, but you can still install other versions of Python separately from Anaconda. Anaconda packs both web-based interfaces of Jupyter notebooks, JupyterLab and Jupyter Notebook. To follow the demonstration, you may install Python 3.9 from python.org. You must install Visual Studio Code as well as VS Code or the code. It's the most popular code edit for its flexibility and versatility. You must install Anaconda 3 in the Visual Edition. For the moment, it's one of the most popular data science platforms. We will use Conda to manage virtual environments and packages. Before you decide to set up this Python environment in your computer, or simply access one from cloud computing servers such as Google Colab or Binder, let's look at the required software components as well as their dependencies. Anaconda has a bundled Python 3. In general, we don't need to install other standalone Python distributions. If a project requires a different dependency with a specific Python distribution and packages, we can always create a new virtual environment. A virtual environment is a tool that separates the dependencies of different projects. This is the most popular tool used by most Python developers. Each project is an isolated environment. These are simply the directories, so that unlimited virtual environments can be created. Anaconda has a Conda out of the box. We use Conda to manage virtual environments. Anaconda is initialized with a default environment base and a default ipykernel Python 3. The pipeline in red is a path of setting up an environment for a new project and add it to an ipykernel. We first create a new virtual environment in Conda. Give it a name, for instance, DS39. Conda allows us to choose Python's version and packages pre-installed during the creation. We can always update the existing environment by adding new packages or removing old ones. In DS39, we install ipykernel package. With the ipykernel, we add DS39 as a Jupyter kernel. Jupyter Notebook has two web-based interfaces available. We can launch both within the environment. For the classical interface, install Jupyter package and launch it by the command Jupyter Notebook. For the modern interface, install JupyterLab and launch it by the command JupyterLab. Alternatively, once the kernel has been prepared, we can develop the project in Visual Studio Code. Two extensions are Python and Jupyter from Microsoft. The code is very flexible with selecting a kernel and editing a notebook. To set up such an environment, standalone Python is optional, but you can find in the video's description the link to 2 videos about installing Python in Windows and macOS as well. You need to install Anaconda 3 and Visual Studio Code with the Python extension. You may also want to install the Jupyter extension. It provides basic notebook support for a few languages, Python, Julia, R, and C# in Visual Studio Code. To help you install Anaconda 3 and Visual Studio Code, please check one guide in the description of video. It's officially recommended that you install Anaconda Individual Edition for the user only. You should make this choice during the installation. For the macOS user, one video chapter is a demo of installing the code and the Python extension. Please use video chapters or timestamps in the description to navigate through the video chapters. The following video chapters are arranged in order. The first 3 are screencasts. I'd like to share with you how I edit script and notebook in Visual Studio Code and JupyterLab 3. Of course, it's neither the best nor the smartest way, but this is the way I feel comfortable with. The following 2 chapters are 2 step-by-step demos. You must have installed Visual Studio Code and Anaconda 3. To make it easy for you to follow me, both chapters are slow-paced demonstration with the verbose mode. Both demos are very important. The first demo is Windows-based. You will learn how to create a new virtual environment in Conda, add it as a Jupyter kernel, test the kernel in the code. The second demo is macOS-based. The commands are the same for both Windows and Mac. The only difference is the first demo test the kernel in code, the second demo test the kernel in Jupyter Notebook. You may want to watch both. The last video chapter shows you how to work with a Python script in Visual Studio Code. You may watch this chapter if you want to know how to install the Python extension for the code. 2 other parts in this chapter are installing the code and uninstalling as well, which are for Mac user only. With an existing virtual environment, which has already been added as a Jupyter kernel, if you choose VS Code as your workplace, the following screencast shows you in the code. How would you select and interpret for a Python script and select a kernel for a Jupyter Notebook? If you say modular not found error, you will learn how to run conda commands to list, search, and install Python package within the code. emphasis on JupyterLab 3, you will see the interface of JupyterLab is different from the classical one in Jupyter Notebook. The operations are based on an existing virtual environment. You will see how to run conda commands in Anaconda PowerShell Prompt for installing JupyterLab 3 and other packages. First demo is Windows-based. You will learn how to create a new virtual environment in Conda, add it as a Jupyter kernel, test the kernel in the code. This part is for Windows. You should have installed a Python extension in Visual Studio Code. It's the one from Microsoft. I have already installed. Next one is Anaconda 3. Of course, we can install Conda separately, but we use the one from Anaconda 3. Anaconda 3 comes with a pre-installed Python 3.8. We can verify this Python in the terminal. From Windows Start menu, you search Anaconda Prompt. Then open the Anaconda Prompt. You will see the same terminal. With the default configuration, the prefix of prompt base indicates the active environment where you are. The Python command in the base will be associated with the pre-installed Python from Anaconda 3. If we will run Python here, base will give you the default Python 3.8. Now let's exit from this Python. With these programs, we can create virtual environment in Conda, add the environment as a Jupyter kernel, and connect notebooks to a kernel in Visual Studio Code. There are a few things I would like to show you. In the prompt part, the default is a base. But do you know where is the base in your computer? That means where is the directory of the base? We can run conda commands. Here, just want to show you. Anaconda 3 has already added the conda into your environment. So we can run conda commands in the terminal. We run conda every list. Every is an environment. Then you will see a list of the virtual environments available in Conda. Right now we only have one, which is the root environment from Anaconda 3. Here you will see this is the location of this base environment. I have installed Anaconda 3 only for the user. So we see Anaconda 3 is in my user directory. The second command you want to try is Jupyter. Jupyter is already available in this base environment. We can list all the kernels by running Jupyter kernel space list. Here we only have one kernel, Python 3, which is from base, this virtual environment. Also here you can see the directory of this kernel. All the kernels in the Jupyter, this subfolder, kernels and Python 3. One kernel is in one folder. So by these two commands, you will see all the virtual environments as well as the kernels and their locations in your computer. With the base kernel, we are able to do Python with 3.8 interpret. In the code, go to Manage Open Command Palette. I first select Interpret. I picked the one outside Anaconda 3, which is Python 3.9. Then I will test Jupyter Notebook Command Palette. This time I will select Jupyter Create New Blank Jupyter Notebook action. By default, the code will pick the default kernel, which is Python 3 automatically. The last thing I want to confirm before we create a new virtual environment as well as add it to kernel. I want to see the location of the kernel. Even though here it shows Python 3 is a kernel currently selected by the code, I still want to see whether code will retrieve the Python interpret as well as the package from the selected kernel. System.executable will print the location of the Python interpret. It is the directory of this Python 3.8 from Anaconda 3. Next, I will also want to see where the code will load pandas from. Is that from the Python 3 from Anaconda 3? I import pandas, then I print pandas location. The output shows the code again load pandas from Python 3 interpret within Anaconda 3. So far so good. Now we are ready to create our first virtual environment. Now we create our first virtual environment. We run conda commands, conda create, For Windows, you must run conda command in Anaconda Prompt unless you add conda into your path. Conda create. Give it name ds.
3.9.
I want to install Python 3.9 into this virtual environment. I want to install two packages, pandas and seaborn, into this virtual environment during the creation. Conda will create this DS39 virtual environment. Install Python 3.9 into this environment. And install the packages I have requested. In order to enter this environment, you can see the command right here. Conda activate DS39. At the same time, you notice this is how Conda indicates the active environment. Once we activate DS39, the prefix turns to DS39. Now we are in DS39. We will install ipkernel in DS39. We use conda install ipkernel. We install ipkernel into DS39, then we can add DS39 as a kernel. Now we have already had ipkernel in DS39. We can add DS39 as a Jupyter kernel. I want to remind you, we do have Python 3.9 in DS39. If you want to verify, you run Python command in DS39. It gives you 3.9.1. This is from DS39. Here shows is a Anaconda 3. Now we can use the Python command ipkernel install user. I only install the kernel for the user. You can use the different name. I use the same name as DS39. This will add DS39 as a Jupyter kernel. Now you want to view all the kernels you have so far. You run Jupyter kernel space list. We do have two kernels. One is the new we just created. You also see the location of the new kernel. Because I have created for the user, the new kernel is located in the user account. In Jupyter kernels, let's also list all the virtual environments. We run conda every list. Here shows the location of the virtual environment. DS39 is in the Anaconda 3 iOS. It's a subfolder. All the virtual environments are in the iOS folder. Each environment will become one separate folder in the iOS folder. Now we have two virtual environments and two kernels. So now we are ready to test this kernel. DS39 in Visual Studio Code. Let's test if we can access the DS39 kernel in VS Code. In order to do so, we open Manager, open Command Palette, create a new blank Jupyter Notebook. The code will always automatically start the server and load a kernel. Python 3 has been selected as the default one. Let's check how many kernels we have. Sometimes you do see multiple copies of the same kernel showing in the list. Let's look at the list. The last one is the one we want to start. DS39 is the name we have added to the kernels. The one above also includes the DS39, however, this one is not the kernel. This one is the Python interpreter from DS39. Here we select DS39 and activate it. Then you can look at the top right corner. It shows the current Jupyter kernel running. You can also test switching kernel from DS39 to the Python 3, which is the base one from Anaconda 3. You just pick this default one. Look at the code will switch from DS39 to Python 3. You can always switch back to DS39. Now, even though the top right corner shows the kernel's name, however, again, we still want to verify the Python interpreter as well as the Python packages, where the code will retrieve this from. In order to do so, we will import this and print this.executable. Run the cell. The output shows the directory of Python interpreter. It's from iWith DS39. It's right. Now again, like we have done previously, we will import Cable, this package for data visualization. We run the cell. Then we try to print the location of the package. It's rotating, that means it's still running there. So here we see the location. It's from iWith DS39 library side packages. It's from this selected kernel. The second demo is macOS based. The commands are the same for both Windows and Mac. The only difference is the first demo test the kernel in code. The second demo test the kernel in Jupyter Notebook. Assuming you have installed Anaconda and Visual Studio Code, open the terminal. By default, Anaconda has added conda into your bash profile. The conda command is available in the terminal. We use conda array list to list all the virtual environments we have currently. Base is the default virtual environment from the Anaconda 3 installation. DS39 is the one I have created previously. Pay attention to their directories. The base environment in the Anaconda 3 directory. All the other virtual environments we use the conda command to create. They are in the Anaconda 3 with this subdirectory. Each environment is one directory. This directory is based on the macOS. You will see the different location in the Windows. Now we create a new virtual environment. Use conda create. You can find most conda commands by using the links below in the video's description. I name this new environment PS39. I specify the version of Python is 3.9. I request pandas and Simon, these two packages. You can request more, separate them by space one after the other. We have created py39. We need to activate and enter py39. Once we run conda activate py39, the prefix has turned to py39 from base. In order to connect a notebook to py39, this virtual environment, we install ipykernel in py39. Then we can add py39 as a Jupyter kernel. Once ipykernel has been installed in py39, we can add py39 as a Jupyter kernel. Then we can connect a notebook to this new kernel. We use the Python command, use ipykernel to add this virtual environment as a Jupyter kernel. You can use a different name from virtual environment for this kernel, but I would suggest you use the same name for both virtual environment and kernel. That will make it easy to remember. The kernel is associated with this environment. After we have installed the kernel in py39, we would like to view this new kernel in the list. We use the Jupyter kernel specie list. Here shows we have already added py39 into Jupyter kernels. Because I have added this kernel for the user only, py39 is located in my user account. Now we install Jupyter into this virtual environment py39 using conda install Jupyter. With Jupyter available, we can launch Jupyter server within the virtual environment instead of Anaconda Navigate. We run Jupyter Notebook to launch the Jupyter server within the virtual environment. The Jupyter server is running in the local host. After we have installed Jupyter into this virtual environment, we can launch Jupyter server within the virtual environment. We don't have to use Anaconda Navigate. Now let's make a new notebook. We select a kernel. We will select the one we just created, py39. In the new notebook, we still want to verify this kernel, even though the top right corner shows the name of the kernel is the one we have selected. We can import this, then print this executable to see the location of this Python interpreter. We run the cell. It does show the location of this kernel is always py39. The last video chapter shows you how to work with a Python script in Visual Studio Code. You may watch this chapter if you want to know how to install the Python extension for the code. Two other parts in this chapter are installing the code and uninstalling as well, which are for Mac user only.